Welcome, everyone, to the deep dive. Today, we're jumping into a really fascinating cosmic mystery, something way beyond our solar system.
Mm-hmm.
Imagine a star out there that's, well, it's just not behaving like any other star we've seen. It's got scientists really scratching their
I
heads.
really has.
And the big question we're sort of wrestling with today is, is this just some natural thing we don't understand yet, or could it be something maybe deliberate?
That's the million-dollar question, isn't it?
We are talking about KIC 8462852, which thankfully has a catchier nickname, Tabby's star.
Much easier to say.
Definitely. So our mission here is to unpack the frankly weird observations around the star. We'll look at some theories, even the really out there ones,
Including those.
and show you the evidence that's just kept everyone well stumped.
Right. So just to set the scene a bit astronomically for you, Tabby's star, it's about 1,500 light years from us.
That's a long way. Light traveling for, what, 15 centuries?
Mm-hmm. Exactly. A huge distance. And the star itself, it's bigger than our sun, about 1.5 times the size.
Okay.
And it really popped onto the radar, not because of its size or distance, but because of some really, really unusual observations about its brightness, its light output.
So this all kicked off publicly anyway, around October 2015 from the Kepler telescope data.
That's right, Kepler data.
Now, Kepler, its main job was looking for planets outside our solar system, exoplanets, right?
Mhm.
By looking for tiny dips in starlight.
Precisely. It stared at a patch of sky, monitoring thousands of stars, looking for those telltale, periodic, small dips in brightness. You know, when a planet passes in front, a transit.
Okay, keyword small and periodic. But Tabby's star didn't give Kepler smaller periodic dips, did it?
Not even close. Kepler saw something blocking a huge amount of light from Tabby's star.
Not just a flicker.
No, we're talking about the star's light dimming by around 20%, sometimes even a bit more, on several occasions.
It's immense.
It's staggering. And the other really weird thing, these huge dips happened randomly.
No pattern.
No pattern at all. Across the, what was it, almost 1,700 days, Kepler watched it continuously. It wasn't like a planet going around predictably. It was just chaotic dimming.
So right away, that's a massive red flag. This isn't normal star behavior.
Absolutely not. And you have to think about the scale involved. To block 20% of the light from a star, 1.5 times the size of our sun.
What kind of object are we talking about?
Well, whatever it is or was,
Okay.
it would have to be enormous, almost half the size of the star itself.
Half the star size, just blocking the light.
Roughly, yeah. Think about that. Something nearly 3/4 the size of our sun just drifting in front.
That's hard to picture naturally.
It is. For what looked like, a perfectly ordinary F-type star, this was instantly flagged. It was unique, inexplicable, really, based on what we knew.
And millions of stars had been watched by Kepler and other surveys?
Millions. And none faded like this. It just stood out completely. A true anomaly.
Okay, so this is where things start to get, let's say, speculative. Because the data was so weird.
Understandably so, when the usual suspects don't fit.
You start looking at unusual suspects. How quickly did the idea of, alien megastructures actually come up? Was it immediate, or did people resist that?
It wasn't the first explanation scientists jumped to, obviously. You always try for natural causes first.
Yeah.
But the data was just so stubborn. It didn't fit no natural phenomena.
Right.
So the conversation did fairly quickly, actually, turn towards more unconventional possibilities, things that are theoretically possible, even if they sound like science fiction.
And the big one was the alien megastructure idea.
Correct.
Right.
Specifically, the concept of a Dyson Sphere, or maybe more realistically, a Dyson Swarm.
Okay, let's break that down for people. A Dyson Sphere. That's not just something from Star Trek, right? It's a real theoretical concept.
Oh, absolutely. It comes from the physicist Freeman Dyson. It's a hypothetical megastructure that an incredibly advanced civilization might build.
To do what exactly?
Basically, to capture as much of their star's energy output as possible. Imagine needing so much power that you decide to essentially build a shell or a network around your entire star.
Like wrapping it in solar panels.
That's a good analogy.
Yeah.
Like a giant spherical solar power station. Or maybe more likely, not a solid shell, but thousands or millions of independent panels or habitats orbiting the star in a dense configuration.
A Dyson swarm.
Exactly, a Dyson swarm. Still capturing immense energy, but perhaps more feasible to construct than a solid sphere.
And a swarm like that, with all those orbiting pieces, that could definitely block a lot of starlight, and maybe erratically as different parts pass in front.
That was the thinking. Theoretically, a large enough swarm, or even large pieces of a partially constructed sphere, could absolutely cause the kind of deep, irregular dimming observed at Tabby's star.
And it wasn't just, random bloggers saying this. Actual scientists were considering it.
Yes, that's what made it so compelling. You had legitimate astrophysicists and researchers putting this forward as a serious, albeit extraordinary, hypothesis.
Because the natural explanations just weren't cutting it.
They really weren't. The data was pushing the boundaries.
Yeah.
It forced people to think outside the standard astrophysical box. It was a real, what on earth is going on here moment.
Okay, but science being science, people did try hard to find a natural explanation first.
Of course, always.
And the main counter theory, the more conventional one, was comets, a huge swarm of comets.
That was the leading natural hypothesis for a while, yes.
Yeah.
The idea was maybe a massive group of comets, perhaps disturbed from their orbits, passed in front of the star.
Right, and there was even a paper published about this, Yale researchers, I think.
Yes, in September 2015, they explored the possibility that a large family of comets could, potentially, create such irregular dimming. Seemed plausible, unusual, but maybe possible within natural astrophysics.
Okay, so if comets were plausible, why is Tabby's star still such a huge mystery? What changed?
Well, this is where it gets really interesting again. The comet theory seemed okay until new evidence came to light. Game-changing evidence. Analysis, looking back further in time, revealed that the star hadn't just started dimming recently when Kepler saw it. It seems this dimming has been happening for
Well, over a century.
a century. How did they figure that out?
A professor at LSU, Bradley Schaefer, physics and astronomy, he did some incredible archival work. He went back to Harvard's collection of old photographic plates of the sky.
Like actual glass photos from observatories?
Exactly. Digitally scanned now, thankfully. But dating back over 100 years, between 1890 and 1989.
And he found evidence of dimming back then, too.
He did. He found records showing the star had dimmed significantly during that period as well, long before Kepler was even conceived.
Wow. Okay, so what does a century of dimming do to the comet swarm theory?
It pretty much destroys it.
How so?
Well, Schaefer calculated the sheer number of comets you would need to explain both the century-long dimming and the recent Kepler dips.
And number was?
Get this, an estimated 648,000 giant comets.
648,000 giant ones, yes. All somehow perfectly choreographed to pass in front of the star, causing these dips over the last 100 years or so.
That sounds impossible, like cosmically impossible, the coordination needed.
It stretches credulity way past the breaking point.
Mm.
The probability is just astronomically low. You can't orchestrate that many comets like that naturally.
So the conclusion from Schaefer's work was pretty definitive.
Yeah, pretty much. The comet theory is out. It just doesn't work with the historical data.
Which makes Tabby's star even weirder.
Exactly. Because remember, millions of similar stars have been monitored. They don't do this. They don't just fade over a century like that. It remains utterly unique.
So, okay. Comets are out. We're back to square one. Kind of that weird dimming, the 20% dips, the century-long trend. It's still happening. Something is causing it.
Something is definitely causing it.
And the possibilities are, well, what are they now? A giant planet we haven't seen? Some other huge natural object?
Those are still on the table, theoretically. Maybe a massive planet with enormous rings or some kind of unusual dust cloud configuration. People are still modeling natural scenarios.
Or the Dyson Sphere idea is back on the table too, isn't it? If comets are out.
It certainly makes the artificial explanation, the alien megastructure hypothesis, seem less dismissible, doesn't it? It survived when the leading natural theory didn't.
Now, didn't the SETI folks search for extraterrestrial intelligence, try to pour cold water on the Dyson Sphere idea?
They did. Their argument, or at least the one often reported, was that they pointed radio telescopes at Tabby's star.
And heard nothing. Silence.
Right. They didn't detect any artificial radio signals, like the kind we broadcast. So they argued that makes an advanced civilization unlikely.
But is that really a solid argument?
Well, that's the crucial counterpoint, isn't it? Let's think about it.
Okay.
If you have a civilization advanced enough to potentially build structures around a star.
Millions of years ahead of us, maybe.
Exactly. Are they likely to still be using radio waves for communication? Something we consider relatively basic even now.
Probably not. It seems incredibly primitive if you're that advanced.
It likely would be. Imagine us trying to detect an advanced alien civilization by listening for, I don't know, jungle drums or smoke signals across interstellar space.
Right. It makes no sense. We wouldn't detect 21st century communication that way.
Precisely. So the fact that SETI hasn't detected radio signals, honestly, it probably doesn't mean a whole lot regarding the presence or absence of a super advanced intelligence there.
It just means they're not using technology we can currently detect or are looking for.
That's the crux of it. Lack of radio evidence isn't really evidence of absence in this context.
Which brings us right back to where we started, in a way. Tabby's star is still this deep, profound enigma.
It absolutely is.
Scientists are genuinely still stumped. The cause of that century-long dimming, those crazy dips, still unknown.
Still unknown. It's one of the most genuinely puzzling astronomical mysteries out there right now.
And it's fascinating, isn't it, how something like this forces science to really confront the limits of its knowledge.
Oh, definitely. Phenomena like Tabby's star are incredibly valuable, even if they're frustrating. They push us. They make us question assumptions, develop new theories, maybe even new physics.
Consider possibilities we'd normally dismiss.
Exactly. It reminds us how much we don't know about the universe and how unexpected discoveries can completely change our perspective. It really makes you wonder what else is out there, behaving in ways we haven't even imagined yet.
Yeah. And here's a final thought to leave you with, something from the material we looked at. It suggested that whatever the final answer is for Tabby's star, the version fed to the public might end up being, quote, whitewashed and anticlimactic.
That's a cynical take, but perhaps understandable given past experiences sometimes.
So let's just speculate for a second. If it does turn out to be something not natural, something artificial, what's the next question you'd want answered? What would that discovery really mean for us, for our place in the cosmos?
That's a huge question.
Something to ponder, anyway. What are the implications if we're not just looking at rock and gas and dust out there? Think about that.